Thank you for joining us for today's webinar, Transforming Returned Concrete from Waste to Resource. We have some brief housekeeping before we start. Your phones are muted. If you have any questions, please type them into the Q&A box in the corner of your screen, and we'll answer them at the end of today's session, time permitting, or via an email after. And you can always send questions to mapeiddigital@mapei.com. We also invite you to visit the Add Mixtures for Concrete page on our website, www.mapei.com, where you can find information about our products for recycling concrete. There's a lot of information, and it all happens to be overseen by today's speaker, the Corporate Product Manager for MAPEI's Re-Con line, Sven-Henrik Norman. Sven-Henrik brings more than 25 years' experience in the mining equipment, quarry management, concrete production, and mix to the construction industry. As the corporate product manager for MAPEI's Re-Con line, which is our product line that focuses on material circularity and recycling in concrete production, he works globally to promote solutions to reduce cost and waste for MAPEI's concrete admixture customers. Sven-Henrik is a non-voting member of the ACI Committee 555, Concrete with Recycled Materials, and he's also a member of the Environmental Committee of European Federation of Concrete Admixtures Associations, the EFCA. And he has a lot of interesting information to share with us today. So without any further delay, Sven-Henrik, the floor is yours.
Thank you, Jennifer. Well, I'm glad and thank you for this opportunity to speak about the MAPEI solutions for a more sustainable concrete production. I'd like to start with some statistics to show why we are promoting the solutions that we are. This is a statistic from the NRMCA of the ready-mix production in the United States. And as you can see, the development, we were in 2023 producing 392 million cubic yards of concrete. And with the industry, we know that there is concrete that's been returned. Between 5 and 10% of all the ready-mix concrete that's produced goes back unsold to the customer, to the producer, sorry, for the reasons of over-ordering, or they might be quality issues. But fact remains that almost between 19.6 and 39.3 million cubic yards are returned, and they present a potential waste stream. This, and in combination with the truck washout slurry, which is another major waste stream that we take care of with the Re-Con line, that's the motivation for MAPEI to be in this business of Re-Con line. So the content of this webinar is I'm going to go through the benefits of the product, more a technical description of what it is, how you can apply it, and how do you dose it in your return concrete. Then we'll have a brief look at the economics, the cost savings and value added by reclaiming return concrete with Re-Con Zero EVO. And then the final section of the end product, the actual aggregates that you get out of this process. So we'll start. First of all, benefits. Reclaiming return concrete into recyclable aggregates. Well, what we have is an alternative solution to what's been available in the market for some years, crushing or wet processing. What we have is a two-component powder product that you apply directly in the return concrete, and the transformation happens chemically and not mechanically. The benefits is, with the two-component powder system, we have a higher quality end product compared to other suppliers on the market that only have a one-component product. It has a very low environmental impact, and it's cost effective. We are not using high investment equipment. We are not using diesel. We don't have any filter press needed. So there is no, the benefits is are low noise, low dust, and very low fuel consumption, because we use the existing machinery on site, the truck mixer or a wheel loader. The real saving is that in a ready-mix concrete production locally, you reduce your waste by transforming it. You don't have to haul it off to a third party to crush it. Or in the case of if you're operating a wet process reclaiming system, you don't have to haul filter press cakes to a landfill. So we reduce those 20 to 40 million tons across America does not have to be hauled away. They go right back in as aggregates in new concrete production. And that's a pure circular economy. And that is perhaps the most important benefit of this product. This is more like a graphic illustration of what I just said. In the middle, you'll have the system of ready-mix production. You have raw material sources that we save on natural aggregates because we are reclaiming the return concrete that comes back. Not in the webinar today is how we handle the truck washout slurry from empty, dirty trucks. That's a separate subject called dry washing. That's also in the Re-Con line. But if we look at the processes on top and to the bottom, those are the processes that we basically eliminate with Re-Con Zero. You don't have to have your cakes and somebody come and collect your cakes or crush them on site, or high investment, high maintenance wet process equipment. So it's cost effective, more economic, and more circular. So the product, what is it? Well, like I said, it's a chemical product. Comes in two components, part A and part B. Both are powder. They are packed in water-soluble bags so that you can handle them safely, even though PPE is needed to be worn, but you have your gloves and you never get in touch with that powder. You see the specifications, the densities, and it contains no harmful substances. We at MAPEI, we have the safety data sheets available if you need them. But those on the picture, you see those actual bags that you will be throwing into the fresh return concrete. By the way, make sure if you have any questions, we'll take them, like Jennifer said, write them in the Q&A field, and we'll bring them up at the end. So the packaging of the product, you could basically order the two components, Re-Con Zero EVO, part A and part B, in a convenient plastic bucket that would treat 7 yards of return concrete. Because you need, as a standard, I will go through the dosage recommendation, but our standard recommendation is you use 1 part A and 1 part B for every cubic yard. Then there is the opportunity to only use part A when the conditions permit, and that will make it even more cost effective, because 2 components obviously a little bit more expensive than just 1 component. So you can buy the products in these two packages. Application: how do I apply Re-Con Zero to return concrete? We have basically three methods that we recommend. The first one is for the normal loads, let's say. Most returned concrete comes back in loads that are less than 4 cubic yards. That's not to say that bigger loads exist. You can have some scenarios where a job goes completely wrong, or a customer orders one truck or even two trucks too many. Then you have those big loads. But the idea here is the driver, if it's a load below 4 cubic yards, the driver can use the mixer truck as the mixing vessel, and in a reasonable time transform the return concrete directly. With the larger loads, that unloading and the whole process takes too long, or it's longer. So we know that concrete drivers are there for the purpose of driving concrete, not recycling in the first place. So by using just basically the ground or a recycling bay, we call it the trench method, the driver can leave his concrete in that bay, and you take care of it. A yard person takes care of it, and the truck driver can then go away and be productive in the ways of driving, getting a new load and driving concrete. The third method is under development. We have a patent, and we are in the extremely interesting process of developing a driverless system, a machine that would do the job of the two different processes that you have on the left. Basically, the driver would empty his return concrete into this machine, the powder will be automatically added, and at the other end comes out a granular material. So these are the three application methods. I will go through the first two a little bit more in detail now. Truck mixing happens in these steps. You look into your drum and see how much return concrete do I have, and based on the dosage guide that I will go through later, you throw your bags into the concrete. It's important that they hit the concrete and not the walls, because if that powder, which absorbs water very easily, if it hits the steel walls, it will get stuck there and create some buildup. So it's much better that it goes into the concrete where it's supposed to be. So you mix intensively, and the water soluble bags will dissolve, and the powder will go out in the concrete, and within minutes you'll hear the sound will change and the consistency of the concrete will change. So in a total of 4 minutes, you have gone from a flowable concrete into what you see in the picture that says discharge. So then it's time to discharge it on the ground, and you let it harden. That's the next phase, where the concrete needs to, the agglomerated concrete needs to dry and harden, because it comes out still moist. So if you leave it in a big pile, it will stay and form a quite hard pyramid. So the secret is here: spread it out, use a wheel loader or skid steer to spread it out and let it evaporate, let excessive moisture evaporate, and let the product work to start the hardening of the granulates. And as a last step, you see, after anything from a Texas summer day, we're talking for 4 or 5 hours, or a New England winter day, maybe 24 hours, but eventually the aggregate will be ready for recycling or selling as a road-based material. So This slide just illustrates again the mixing procedure. That it's important to break up the bags so that it takes about 2 minutes for the concrete in itself to break up the water-soluble bags and dissolve the powder in the concrete. And then it's important to make the most of the mixing procedure because you want to clean the truck at the same time. So to rotate the drum backwards and forwards a few times, that will make sure that you clean your wings on the inside of the truck on both sides, and you really utilize the most of the product. So you end up with a very clean truck, and you have transformed all the return concrete that's in the truck. Discharge, again, you listen when that's your ears are probably the most important tool here, unless you climb up the ladder and look into the drum. But you will hear when the concrete goes from this fresh state to the granulates. And when you hear that, it's time to reverse the drum and empty the material on the ground. And try to do that as quickly as possible, especially if you have very big loads. You could risk that if you keep turning the material around, the concrete around, you may, after let's say 10 to 15 minutes, the superabsorbent polymer that is part A can no longer hold the water, and the water will go out back into the concrete, and it will then be more like a concrete than the granulates. So speed is important, and that's again why when we have bigger loads than 4 cubic yards, that we recommend to do that outside the truck so that the discharge time will not create that risk. And don't build high piles. Try to fan it out as much as possible, because it makes it easier to turn the material around and get that evaporation going over as big surface area as possible. And then your material dries out and you don't form the lumps that you need to break. Some lumps you probably have to break up with a wheel loader, but it's much easier if you have the space available and you spread it out in the first place. Hardening, as I said, it's temperature dependent. So it could be anywhere where it's 40 degrees, it will take you up 30 hours, or if you're in the 70s or 80s, it's 4 or 5 hours. So that's a chemical process, and the chemical process is depending on the temperature. You can, if you want. We've experimented quite a lot in Scandinavia and some customers in the US, where you can really save space and time by, instead of using the wheel loader bucket as your, let's say, crusher to break those lumps that may appear, you can use a machine, a shovel attachment that has a kind of a crushing action to it. There are many different manufacturers. In US, there is some product called Hog Crusher. Alu is also another supplier. MB Crusher from Italy. So this could be an extra investment, but it's a tool that can really help in making really high quality aggregates, especially when you're looking at recycling it back into concrete. The top size of the aggregate is very important if you, for example, you want to do pumpable concrete, or so that's a third party equipment that we would recommend, or we could help you with selection. the dosing of Re-Con Zero EVO, it is simple and complex at the same time. I'll start with talking about the different roles, and that, I think, in a way explains the whole concept. Part A is a water superabsorbent polymer, and its role is to flocculate and bind the water in the concrete. You have in a cubic yard of concrete maybe around 50 gallons of water. That's what makes the concrete flowing. So if we can bind that water, we'll kill the slump and we'll start that reaction. So that's the role of part A. And as if you read the screen, you'll see also the details of that. So part A is there to bind the water. Part B is a setting accelerator, and its role is to really kickstart the reaction between water and cement. So we flocculated the cement and the water, because in concrete the cement paste is the mix of water, cement, and some superfines from our sand, and that is what we're flocculating, and we're making that cement paste form some lumps and also attach itself to the larger stones that are in the concrete. So if we have a high water cement ratio in the cement paste, if we have a low temperature, this setting accelerator can really help to speed up that process. So that's the role of part B. And the whole system, how much to dose, are based on the 3 parameters on the top of the page: slump of the concrete, the outside temperature, and the load size in cubic yards. And I guess some of you have already got your phones up and pointed it to the camera to that QR code, and you're very welcome to do that. That was the purpose of putting it there, because this will take you into a dosage guide, a web-based dosage guide that will tell you in very simple steps, or tell, for example, your driver or your supervisor in the yard who's helping the drivers, how and how much to dose. And there are then the exceptions, the extreme cases, very low temperature, very high loads, etc., that will be explained in that app. So just to comment on that, in most cases, part A and part B can be thrown into the concrete at the same time. The ideal, if you look at our product data sheet, for example, we have different scenarios. The ideal is to put in part B first, because that helps kickstart the accelerate the hardening, and then you use the part A. But we know that this is a quite complicated, and for drivers who are in a hurry, we want also simplicity. So this is the trade-off that we have to do. So in that case, we say that our standard mode of operation here is that you throw in part A and B at the same time, but the app states some exceptional cases. For example, very big loads. If you have your 4 yards and you want to do it on a very cold day, and then we know that throwing in part B first and letting that setting accelerator first work on the concrete will be beneficial to the end quality. The app will tell you that. The app will give a comment that we would recommend throwing the B first. So I think more and more these kind of apps are a good communication. I know for myself, I very rarely read manuals before I do something, but if there's an app, I will look at it and use it as a guide when when I need to. But if you're in doubt, if you're standing, our goal is that a MAPEI sales representative would be there for you as a customer to guide you through the first, if you've never used it before. So the combination of a MAPEI specialist and this app hopefully will make it easy to train the drivers on how to use the system. Then we go to treating the larger loads and using the trench method. And as I said before, this is about making the truck driver available for a new load quicker, because a big load, that it first of all, it puts some stress on the concrete truck mechanically to process big loads. And I know actually American concrete trucks, but I know this from testing. American concrete trucks are much tougher than European. So I have done demos in the US with big loads, and they work perfectly fine. So take this as this could be a recommendation. It's a little bit European. I apologize for that, but we have to keep in mind, so the mechanical stress of the truck is one thing, but then the time that it takes, that's the same in Europe as 1 minute is the same in Europe as in the United States. So to hold up the driver for a long time can be negative from the cost point of view. That's why we looked at the trench method, and it's very, very simple. Basically, you build up a 3-wall bay with concrete blocks, and if you want to, you can line the floor with some Re-Con Zero aggregates that you've already produced, because that will help soak up some of that moisture, and it will help the agglomeration of forming the aggregates. So that's easy. Just be aware that that back wall should be very, very sturdy. Back that up, because as you will see, well, we'll come to that later. First of all, you use this bay as a pool. So the concrete truck fills up the bay, and then he's free to go. He can go to the next job. You evaluate the load size and wetness, etc. You can use the dosage guide for that as well. And then you add the Re-Con Zero powder by throwing the bags into the concrete. Having done that, you use the wheel loader to turn this material over and over and over. And very soon, in a matter of minutes, the aggregates will start to form, and you will transform the wet concrete into granulates. We have a video on this process. For technical reasons, we chose not to show it to you today, but it can be part of a info package that we will send out on the completion of this webinar. So that was the two major methods, and then the driverless system is going to come and going to be introduced in the US in the future. So we'll have an opportunity to come back with more details on that machine. But now, very important is the cost and potential savings from using Re-Con Zero. We made this little cost sheet, and it's based on 2 scenarios. One to the left is where you have to use the two components. Again, cold temperature or very wet return concrete meaning a high water cement ratio in that concrete. So the two components are needed. Scenario to the right is where you can just use part A, because the slump could be 6 to 8 inches, and you have a temperature of about 60 Fahrenheit or something like that, then you'll be fine to do just with the one component. So the prices, that's the list price of the treatment per cubic yard. But when it comes to transforming flowing concrete into a granular material, we have to convert to tons, because the material that we get, and from in each cubic yard of concrete there are 2 tons of material. So basically you see from $15 using the 2 components, if you get 2 tons of material out from that concrete, your cost is half. Then it's only $7.50. So the bottom left of this model is where, if this is available as an Excel sheet, so your MAPEI sales representative will have this with him, and you can type in the cost of virgin aggregates. We used a generic value, $20 per ton, and then the market prices of if you sell as backfill, and then some standard. What's your, in this case, it's a production volume of 50,000 cubic yards per year, and the rate of return concrete is 5%. So this model works its way downwards to give you the savings in if per year in dollars, if you transform all your return concrete with the help of Re-Con Zero. And you see there's a considerable saving, either if you sell it as backfill, $12,500 per year, or if you can use it as virgin and replace virgin aggregates. You save also the cost of virgin aggregates. So there's considerable savings with this method. Another way to look at the same problem, we've used a slightly higher production volume. In this example, it's 100,000 cubic yards, 5% return, and the raw material cost, same as previous example, $20 per ton. But now we want to bring in a factor which we see is increasing globally and also in the US, is the fact that the distance from your concrete production to the distance from your raw material source to where your production is, or the distance from your concrete production to a waste site that you need to take your waste to, seems to be increasing. If we go back in time, maybe 20, 30 years, there would always be a sand pit near your ready mix plant. So transport was never a big problem, a big issue. But we see now in the big urban areas, and because we are using a lot of raw material, natural sand is getting more and more scarce. So our distance from the distance from the raw material to the ready mix plant is increasing. So this graph here is, we can call it a sensitivity analysis, because the bar on the far left, this is where you have access to a fairly local source of raw material, and you don't have to haul your waste for very long. The two scenarios, then, the two lines that they represent, as you can see on the left scale, on the Y scale, sorry, is your total annual saving in US dollars. So scenario A, the red line, is if you don't pay anything for return concrete. There are places where that have contractors that would come in and collect your return concrete, or in the but we see a trend that that is less and less common, and more there is a cost element to handling return concrete, and we used a generic number here again, just for the example of $10 per ton. Transport cost, again generic, you would pay somewhere 20 cents per ton per mile. That can vary, and this model can obviously be adjusted to your personal conditions. But you see, as what happens on the x-axis is that the different examples where the transport distances increase, then the orange bar, which represents the total transportation cost, that's what you're saving by not having to transport that material. You're having a local production of your own aggregates right in your own backyard, and that leads to a considerable savings potential, as you see on the Y scale. So to recap on Re-Con Zero and the benefits: very low environmental impact, it's cost effective, and you have, like I said, you have a aggregate factory in your own backyard by transforming the return concrete into an aggregate material. There is very low, basically no investment in equipment needed, and especially if we compare to the processes below and above, either a wet washing process or crushing equipment. And if we take the example of crushing process, we have Re-Con Zero have very low noise, no dust. So if you're in an urban environment, you can do that, and it will not create complaints with your neighbors on that you're noisy and dusty with your return concrete treatment. And you're reducing haulage cost, less waste that goes out of the plant, and less raw material that you have to bring in. So that's, in summary, the advantages of Re-Con Zero. So we move to the aggregates. What do they look like? What can you do with the end product? So here, this is a complicated graph, I know, but I'll walk you through it. It's a screen analysis of Re-Con Zero aggregates. If you look at the blue line, represents a typical aggregate as it would be before it's mixed into concrete. So we know that concrete is a mix of sand and stone and water and cement and admixtures. So what you get out is exactly that. When you add Re-Con Zero, all the powder is doing is that it's agglomerating, as you can see at the lower end, the very, very fine material. The gradation curve of Re-Con Zero aggregates, it's much coarser because it's agglomerated into bigger particles. So we've had customers who investigated this and can then sell this as a base course aggregate, unless you want to recycle it into new concrete. So the green dots, they represent the the limitations, lower and upper limits of base course material. And you see that we are a little bit low on the fine end, but that can be very easily helped by mixing in some finer sand. And we're a little low on the higher end, which means we would probably need to screen out some of the oversize. But having done that, you have a material that then can be sold as base course material. And this is, of course, if to satisfy standards. To the private sector, domestic use, those standard limits are not as strict. So then you could sell it as an all-in material for domestic use. Customer in Colorado used this material to make his own access road in and out of the concrete plant, and it packs really well, and it's at the same time it drains really well, so it can handle very heavy turning traffic, cement trucks coming in, aggregate trucks going in and out of the plant, concrete trucks constantly on that road, and it's a very, very good road base material. And again, to make it a little bit simpler, this is a graph that just shows you how a typical gradation of aggregates. When we look at using recycled aggregates back into new concrete, we will have to do concrete tests, and that's exactly what we've done. We've used American materials, American cements. We did the tests in Texas, and we used different replacement ratios of Re-Con Zero EVO aggregates, and we tested the strength of that concrete 1 day, 7 days, 14 and 28 days, and we found that if we use a system of MAPEI admixtures, and that means Re-Con Ag 100, which is a water absorption inhibitor that helps keeping the slump high, even if you use recycled aggregates at high replacement levels. We used the Dynaman admixtures as your normal water reducer, and we use a strength enhancer called MAPEI 60. So the combination of those chemical admixtures made it possible, as you can see, to replace up to 30% of virgin aggregates in mixes with Re-Con Zero aggregates and remain at an acceptable strength of the compressive strength of the concrete, and also the workability. And this is with 30%. So remember, if your return concrete is only 5%, or even if it's 10%, if you can mix that back into any kind of concrete, then you will have very, very little effect on strength and also on slump. But then that it's not always possible. You have to maybe concentrate your replacement into residential mixes and non-frost resistant concrete. So you might have to get a mass balance mix levels of 10, 20, or in some cases where you may want to really market the concrete as a circular material, environmental material, then 30% replacement is not a problem either. So we are basically done with that slide. I've gone through the benefits of using Re-Con Zero, a little bit about products, the product itself, how it's packed, etc., some of the application methods, cost and benefits, and then now finally the end properties of the end product. So that's the end of my presentation, and I'm now open to any of your questions. So Jennifer is keeping track of the Q&A box. You have anything on
We
the
sure
questions?
do. Yep, and thank you for a really informative presentation, Sven. The first question is, can you please explain the two different components of the product and what they do?
Sure. Let's go back again to repeat. I know this can be a little tricky. So I go back again to this slide. Oh, let's go back even further, because here you see it actually. It's easier. Part A is the bag that the bag is tinted blue. Both products are white in color, but the blue bag is colored in blue, so it'll stand out. That's your super absorbent polymer. That is the same chemical that's in kids' diapers. It will absorb 500 times its own weight in water. So that is there to kill the slump of the concrete. Part B, the white bag here, is the setting accelerator. It will help you to, when other products in the market will sort of miss out or won't be as efficient, this part B will help in colder temperatures during the winter with concrete at high water cement ratios. Let's say the driver has wetted his concrete. He has had a long drive back from the plant, from the customer, and he's put in some water. So you are not really sure the water cement ratio of the full concrete mix. The part B will be there and almost act as a cement, let's say, or it will activate more the cement set that's in the concrete. So that's the two components.
All right, very cool. We have another one coming in. The cost efficiency is always important when looking at new technology. And can you elaborate on cost and benefits of using Re-Con Zero?
Yeah, sure. Let me go back to this slide then, because this is where I talked about the cost and benefits. So on the cost side, let's take an example. I know I used in the presentation, I used the left column where we're using both part A and B. Let's look at when we're only using part A. So your cost of the powder, what you pay MAPEI, let's say, is $7.50. So to explain that in other terms, is that what is the cost? Well, it's $7.50 per cubic yard, but it's $3.75 per ton of material. And that's, why do we say that? Well, that's because we compare tons when we look at either purchasing new raw material or when we can sell it as a backfill material. So that is where the calculations come from. So if you are able to sell the reclaimed aggregates as backfill, your total saving in the case of 50,000 cubic yards a year, 5% returned, you're saving $31,250 a year. But if you can use them as replacement of virgin aggregates, which are much more expensive, you're saving $81,250 in this example. So, and that's with basically no investment in equipment. All the cost is there is no um, no investment cost or maintenance on that equipment. It's basically just the cost of the powder.
That's awesome. That really is.
Yeah.
It really does turn it into a resource. That's just what a great thing.
It does. Yes.
Yep. Yep. Okay. It says, does the use of Part B increase the SO4 content? I know that SO4 is it.
Yeah. No, we have tested concrete or the aggregates, and the total sulfur or is below limits. Chloride content of the concrete is below any limits. So, and remember, it's only a pound. No, sorry, 2 pounds per cubic yard. So 2 pounds per ton. So it's a low amount that we're adding, and it has no effect on total sulfur or any of the important, let's say, ASTM requisites for concrete aggregates.
Fantastic. Thank you for knowing what SO4 was. High school chemistry was a long time ago.
Yeah. Same for me.
Yeah, well, we'll give it a few more minutes as people think, as I know
Yeah, sure.
if people are like me, the second we click off, that's when the questions start. And if that
Yep.
does happen, and after we say goodbye, questions arise, you can always send them to us at mapeidigital@mapei.com, and we will get them to Sven Henrik for sure. But yeah, thank you
Yep.
for a fantastic presentation.
Yeah. Thanks, Jennifer. It's a pleasure. And I have to say, if you have questions, yeah, by all means contact me. But also you can reach out to your local MAPEI representative, because I have been spending a lot of time with them, and they in turn are becoming real experts in doing demonstrations and to answer most of the questions now, because it might seem complicated at the beginning, and it does take some training of drivers and change of mindset for people, but once you do that, and I think the cost, okay, the green values, saving the environment, that's important, but we know that we cannot do that unless you have a solid cost efficiency in the product itself, and this is what we think we have, and our MAPEI specialists will be able to guide you through the whole process. And we do have manuals, and I believe that app will also be a very helpful tool.
Oh, that app, absolutely. Yep. Yep. Fantastic. Well, thank you everybody for joining us. We know that your days are very full and they get very busy, and we really truly do appreciate the fact that you spent some time with us today. And we look forward to seeing you at the next webinar. And thank you again, Sven. So
Thank you.
thank you. Bye-bye, everybody.
Thanks. Bye-bye.